practice, the more you learn, right? And again, of course, programming is all about customizing to your requirements, and that would require some basics and also a bit of, logical thinking. So let's get started, and we'll begin with a short presentation. So just to highlight why are we learning R, and then of course I'll take you through the interface, R Studio. And today we'll do the basic data types. We'll see how far we can go today, and based on that, of course, we can take it forward tomorrow again. Right. So I hope all of you are absolutely new to R, or some of you already know a bit of R programming. So I think some of you might know a bit of R programming, so that should not be a problem, right? So let me share my screen first, and then we go for a presentation first, and then of course we'll get into the real interface. So let me share my screen, and there you are. You should be able to see my screen now, and this is a bit of confusing, but I guess can you see my screen now, class? Everyone? Okay, thank you. So thanks for confirming, and let me just hide this panel here. So first thing, of course, is why do we need to do programming, right? This is asking me to leave meeting. Just a minute. I click something that does the one I want. Control L. Okay, so Control L. I was trying to take my laser, but it doesn't allow me. So anyway, that gives the pointer here. So this is, I'm sure you know Steve Jobs, and this is basically your co-founder of Twitter and Square, Jack Dorsey, and both of them basically emphasize on the importance of programming here, right? So everybody in this country should learn to program a computer because it teaches you how to think, right? So all programming is about how do you translate what you want to do into a certain language that the computer can understand. So therefore, it is important to learn a bit of programming. And today, as biotechnology moves into a data-driven, science, it is all the more important for everybody, not just the bioinformaticians, but also the regular students who do wet lab, to get into programming. At least the basics must be clear to them so that you can, process your data fast, quicker, and also if you're going into NGS and other based technologies, which obviously you will go into because now everything begins at next generation sequencing. So which means then that, you need to have the basic know-how of programming. And then, of course, you have Jake Dorsey who says, code, code teaches you how to face really big problems, right? And there have been times when I've been coding the whole night trying to figure out how to work the best way out. And many a times when you write a program, the first thing is to get the output the way you want. And then you get about thinking about how to make it memory efficient and space efficient, right? So we'll talk of this more as we go along. Then, of course, let me just move the slides, and here you are. So R, of course, if you know, you have a command line setup also, so you can directly do on your terminal. But most people now prefer to do what is known as the R Studio. So what people now use is R Studio. What is R Studio? It is a integrated development environment. So this is a better term for graphic user interface. And basically, what people are trying to do here is to develop a basic syntax and a column and some integrated software so that it eases your way of doing R. It is not just a black terminal where you're using your codes and you're basically running your program. This is a more sophisticated and a more easy way to take R forward, right? And so this includes a console, syntax highlighting editor that supports direct code execution, as well as tools for plotting, history, debugging, and workspace management. So this makes life a little easier than doing it on the actual command line, right? So this is an interface that allows you to do R programming a little more easily, a little more, a little more subtly, not the hardcore way. So let's get back to why R. First important question is why are we doing R in the first place? So there are several reasons why R becomes important and takes a center stage today in biotechnology and elsewhere. Why I'm talking about biotechnology? Because we are largely biotechnology backgrounds, but it is not that it is being used only in biotechnology. It is used in everything, starting from engineering to every other field, right? So R is a statistical package for information. And why do we need a statistic? Because you have a large amount of data and you need to separate out the signal from the noise. So statistical tests allow you to, figure out what is the best information from the data that you can churn out, and they support your information that you're finally inferring, right? So therefore, let's see why R is so important. So one, it is developed by statisticians. It is excellent for statistical computing and analysis. And as we move into big data analytics and biotechnology, statistics becomes again a center stage. And to apply statistics onto data, R is the way forward, right? You can also do it in Python, but R is specifically software developed for statistical analysis, and therefore it eases your life a lot more than any other language can do. And then, of course, there are other languages that are comparative. There are other statistical packages that are available. So you have MATLAB. MATLAB is also a statistical package, but that is a paid one. In contrast, R is open source and largely free, right? So R is an open source programming language. Anybody can contribute to its development. Anybody can do the quality control, and anyone can work with license without any license fee or a license requirement, right? And due to this, R has a huge community that contributes to its environment. And therefore, now we have what is R Studio, which has been developed again by the community to facilitate new beginners to be able to work with R, right? And then, of course, we'll get into the details as we go along. Then, if you look at this, a large variety of specialized libraries are present. So there are specialized and directed libraries for specific type of functions. So you may not need to do the hard coding all the time. You may directly call a library up into your program, and the rest of the work will be done by the library itself. Of course, you need to know the nitty-gritties of how to input the data into the library, how to work out and other things. But generally, you have a large number of libraries available for specialized jobs, and you don't really have to do the hard coding for everything. So that makes it even more easier to do it. And then, of course, R Studio is there. It is a graphic user interface or integrated development environment, which is easier to grasp and learn. It has cross-platform support, so R is available across platforms, and it is machine independent. You could work on any machine and on any platform, any operating system, and R is available. And you have a R Studio and a R command line available for each of these operating systems and platforms. And then, of course, R can do data cleansing, data wrangling, and then scrapping, right? So basically, data cleansing, so sometimes you may have an NA value in your data, which will otherwise confound your analysis. So you can remove that NA, or you can say that if there is an NA, ignore that NA value and take the rest of the values and measure the average and so on and so forth. I'm giving you very simple examples. These are more complex. So class, you're following. Am I going too fast or too slow? Anyone who can just raise hand and tell me that it is all fine? Students? All right, so all fine is what I hear, and I see some of my students already joined. So, okay, good. Thank you, Sophia, right? Sophia is around. All right. So coming back here, and we talk more about this now. So everybody says it is fine, so we'll move on and we'll talk. So I'm typically a teacher, so I have this idea of taking a feedback every now and then to see whether the students are following or not, or whether everything is going fine or not. And there's a bit of dim light at my back end. I don't know why that has happened, but that is fine. So can do data cleansing, data wrangling, and web scraping. So R can collect data from the internet through web scraping and other means, right? It can also perform data cleansing. And so I've told you, you can have your NA removed, and you can basically sort out and filter out data that you want. And it is also useful for data wrangling, which is the process of converting raw data into desired format or easier consumption. So one of the primary requirements today in biotechnology is, like, let's say I'm using a third-party software for my analysis. The first thing is that the third-party software would take data in a specific format. So a lot of time goes into reformatting your data the way it is required by the third party. So that is what is data wrangling. And many times in biotechnology, you'll be doing this very often. You start with one software, you do an analysis, the next software in line would require the data in a slightly different format. And therefore, you'd be doing your data wrangling. So R can help you do that as well. Then, of course, one of the important points with R is that R has what is known as ggplot package, which is also known as the grammar of graphics package. And most of the graphics that you have, and you also know that today, because the data is huge, a lot of research also goes into how to visualize your data better, right? And from your conventional graphs of column and lines, we have moved on to many other things like, you have Circos, and you have many other heat maps and these and different types of graphs. So R has utility here again. You have what is known as ggplot2, and ggplot2 can be used to basically develop quality graphics and visualizations which are required uh, for your publication quality, right? So therefore, this is an added advantage that you have. Everybody else, mute. Deepika Sharma, can you please mute yourself? Right, thank you. And then, of course, this is compatible with other programming languages. So R is compatible with other languages like C, C++, Fortran, Python. Deepika, can you please mute yourself? Miss Deepika Sharma, can you please mute yourself? You have left the meeting. Great. Disturbance, please, right? I don't tolerate any disturbance in my class. All right. So then, of course, if you move on, so compatible with other programming languages, R is compatible with other languages like C, C++, Fortran. Other languages like Net, Java, Python can also directly manipulate objects from R. So this is the interoperability of these languages also allows you to take out output from one particular program and take it back into R or the other way around. So that also is important. So that I've given you enough reasons to why you should be learning R. First, of course, it is a statistical package, a dedicated statistical package. It is free and it has a large number of, specialized libraries. It has a graphic user interface. It has a cross-platform support. It can do cleansing, data wrangling, web scraping, powerful graphics, and of course, it is compatible with other such, languages. So therefore, it allows for interoperability. And of course, compatible with high performance computing and big data analytics. This is where we're moving. I'm sure you would know that big data, I'm sure you know, it is characterized by veracity, and variety. And until now, social media is the biggest data that is generated, but it is predicted that in the next 5 or 10 years, biotechnology will generate the maximum data. The biggest data will be generated in biotechnology. So therefore, you need to take care of that as well, right? So, and therefore, you need to be ready for that kind of situation where you can actually, take care of or analyze data based on programming languages. So here you are, and today is our first session. So today we are 7 to 8 p.m. We're already, I think, 7:15 around. Yes, we are at 7:15. R interface, R Studio installing packages, data types, data structures. So today we'll be largely doing R Studio interface, and then of course we're looking at basic data types, vector, matrix, and data frames, right? And then of course tomorrow we'll continue with this, and we'll move on. And of course we will not go too fast. I understand that you guys are pressures, so while I can, concentrate a lot of things in one talk, it will not be of much help. So what this talk is going to do is to introduce you to R in a very subtle and graded manner. And you would also know whether you are suitable for it or not as you move along, right? And of course, any programming language has its own novelties and its own subtleties, and of course, it depends on how much you put in, right? And then in session 2 tomorrow, we'll do a bit of data analysis with R, and if time permits, I'll show you some basic graphs using ggplot2. And demonstration and practice is what we'll do. So this is 2 sessions which we are going to do. This is a beginner's level talk. We are trying to introduce you to R, expecting that you don't have a prior experience with R, so we'll go a little slow. And of course, we can move on as we. And now we gradually move into slightly advanced level and plot data using ggplot2, which is the gold standard for graphics in academia, right? Now, one thing that you must know, and your expectations must be realistic. So not everything can be taught in a limited type of the workshop. You will not become an expert in R after attending this workshop, right? But of course, you will get a fair idea of R and if you're compatible with R. So one thing is, not everybody is compatible with programming. So if you're not into programming, if you don't find it comfortable, that's not a problem. But if you do put in the effort, you would slowly get the feel and the heck of it, and you'll be, you'll be doing wonders. And I'm not a trained programmer for information. I learned programming during my PhD in CCMB. I had some spare time, so I started with Perl. And then, of course, that was a savior for my PhD because ultimately in my PhD, I started with the wet lab, but then I moved into dry lab and published a pipeline for genomic rearrangement. So this could be an additional skill that could enhance your CV really well. Then learning will come when you have a real problem in hand, right? So what is also important is when it comes to, okay, now you have to do it, that is when you really put in an effort and you do it. So it will come, and when you have a real problem in hand, persistence and regular practice will make the learning curve a lot easier for you. So what is required is persistence and regular practice. It should not be that you learn a bit today and then for next 2 months you don't go back to your R studio and don't do anything. Then of course you're not learning much, right? So you have to ensure that you keep going back and keep trying things and keep learning things. And a lot of online discussion forums, YouTube videos will come in handy if you make a sincere effort to learn. So ultimately, the onus is on you. We have 2 sessions. I'll try my best to give you an idea of a fair idea of R, and then of course we can see how it goes. Right. So here is our first thing. So how do you download the R Studio? So this is the link here. If you see here, let me copy the link, and then I'll take you to the link here and show you where you can go to download R Studio, right? So if this is the URL here, I can give you in chat if you want. And how do I see the chat here? I'm sharing my screen. Let me stop sharing maybe. And then, okay, I can have a chat here. So I'm pasting the link here for everyone to download the R Studio. I hope it is gone. Yes, it is there, right? So you can click on this link and it will take you to the page where you can download your R Studio. And depending on what functionalities you have, as in which operating system you have, you can basically download your software here. So this is your rstudio.com products RStudio download page here. And it says download the RStudio IDE. If you go down here, it will show you choose a version. And what you're supposed to download is the RStudio desktop version, which is an open source license and it is free, right? So that's the most important point, right? We're not supposed to pay anything here for the beginners. And of course, when you take a commercial license, you'll have additional utilities. But for now, you can start with the free one and that will work for you. And it is integrated tools for R. And if you go down here, you will have your further how do you install. So it will suggest you what is best suited for you. And then there are other operating systems. Depending on which operating system you have, you can download this exe file, right? So for Windows 10, 11, this is the one. Mac OS, this is the one. Most of you would have Windows. Some of you may have had, some of you may be fortunate enough to afford a Mac for now, so which is fine. And then, of course, if you're into Ubuntu or Debian, then this is the one. So Ubuntu is another Linux, flavor, and you can use that. Fedora or Red Hat, again here, and then again for Red Hat 8 is here. I don't think you'll have Red Hat or Fedora on the systems. At max, you should be either having Mac or Windows or Ubuntu, right? So you can download the required file from here. So, and once you have downloaded the file, this is an exe file. You can directly double click on the file and that would allow you to install. You can just keep saying next, 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 and it will be able to install your R Studio, right? So I hope all of you are now downloading R Studio. Some of you may already have. How many of you already have the R Studio? Anyone who has the R Studio? All right, so Saurav already has R Studio installed, which is nice, and Usha Kiran is joining the meeting. All right. So good. So far so good. So I hope you are downloading this. And then of course, in the interest of saving time, I will now directly take you to the R Studio. It should not be so much of a problem. You should be able to directly download and do clicks on it, and you should be able to install directly there, right? And Harshita raises a hand, so which means that she has downloaded, right? And then, of course, once you have downloaded, you need to go to the search column here and type R Studio so that you have your R Studio. I typed something else. Sorry, guys. R Studio. So my R Studio, it will show up here. I can double click here and it will take me to RStudio, right? So let me take my RStudio is already open, so I'm taking you here. And before starting, let me clear out things here, right? So let me just remove this panel here. Let me just remove everything here so that you know how it looks like. And then of course, this one I can close here, right? And I can partition it here and I remove everything. So when you basically install your RStudio and open it for the first time, it will look like this. There will be 4 panels. Everybody here, class? Right? So when you install your RStudio, it will look like this. You'll have 4 panels. The first panel is where you can write your scripts, and we'll come to this in a moment. The bottom panel here will be what is known as the console, right? And this console is where you can again type and directly give commands. And I'll come to this in a moment and show you how this works out. Then you'll have a third panel on the right-hand side, the top panel here. This is basically your environment panel and also your history and connections and tutorials. So this will give you idea of which variables you're using and other things, and I'll show you as we go along how this works out. And this last panel here is for, for packages. You can install packages here, update packages here. You could see your plots here when you do your plot. You could use your help. You could search for anything that you want to, any command that you want to search in R, and it will link it to, it will give you the link and you'll be able to see it, and so on and so forth. So there are 4 panels here, and by default, it will be here in files, and by default, it will be in packages, I guess, right? So, it is in viewer. By default, it will be in viewer here. So there are 4 quadrants in a typical RStudio. How many of you have installed RStudio and opened the panel here, class? Anyone? Okay, Saurav again, and I think others haven't installed yet. So what we'll do is, because in the interest of time, we'll not have enough time to wait for everybody to come up here. You can follow it up here, and then of course you can practice it at home at your end once I've installed, right? So meeting recording is in progress. Okay. So everybody here, class, you're following, everyone? Raise your hands quick. All right, so everybody is around, and I see a lot of hands raised. Good, so that is progressive here, right? So that is encouraging. So coming back here, this is your scripting panel, and Nilanjana also raised the hand. All right. So here you are, class. This is your typical, and everybody else, and Priyanka Sharma. All right. So coming back here, class, this was your typical RStudio lookout, right? You'll have 4 quadrants. The first quadrant is where you can load your pre-written scripts and run it here, right? And I'll come to this later. First, let us come to console, right? And first, simple idea of how to use R is, let's use R as a calculator, right? So if I give it, let's say, 2 plus 5, right? And say enter. So if you see here, it gives me 7, right? So there's a simple mathematical operation I can do here. Then, of course, if you say 5 asterisks, 5 plus, let's say, 1000. So this is again simple 5 asterisk 5, 25, 5 minus 5, 25. So console is a place where you can give your command and also see the result right away, right? So 5 minus 5 is 0. 5 raised to power 5. So 5 raised to power 5 here would be, you'll use the carry sign. So this is your carry just above 6 with shift. 5 raised to power 5 will give you 5 raised to power 5 times, right? So this is your, all right, so this 5 raised to power 5 times, right? So this is giving you 3125, right? And then if you have 5 raised to power 2, so that will give you 25, right? So 5 raised to power 2 is 25, right? And you can do a lot of such mathematical operations here straight away. Should not be too much of a problem. So this is basically just to show you how the console works. You can directly give your command here and get the output here as well, right? But what we most commonly do is, what happens is when you close the RStudio, whatever is in the console is lost. So this is a data that is not stored, right? And many a times what you want to do is once you've done your operation, you want to save your script, right? So for that, what you can do is you can write a script here, right? And let's say I write again 5 asterisk 5. And then again, if you see here, I select this and I say run. And again, if you see in the bottom, you get 5 asterisk 5 equals to 25. So let me load a pre-script, a pre-written script for you, and that should help you understand what I'm saying. So I'm now loading. So you go to file here, right? And I'm opening a file. So I'm browsing through my system to open a file. I'm in my local directory F in the folder F into the R human genome folder, and I load a file called R as calculate, right? So this is my first script that I'm showing you. So here is a pre-written script, right? So what I'm doing now is I'll simply select the commands here and look at the output in the console, right? So here you are, simple arithmetic operations, 1 plus 2. So you have to select that. And what is this hash and the command here? So this is what is known as comment. So when you put a hash in front of a line here, that line is not basically executed, right? So you can write your comments using a hash. And why do you write comments? Because you want to know what you're doing in this part of the program, which is very important again, because many a times what would happen is when you write a long code, let's say 1,000 lines, 10,000 lines, 5,000 lines, you would yourself not remember what you have done in that part of the program. So therefore, it is always important to comment your program, whether you're doing it in Python or in BiPython or in R, right? So for here, for example, I write simple arithmetic operations, right? And then I select the first line and I say run, and I get 1 plus. So let me just clear this out so that you see only what this is. So this is the brush here. When you click on the brush icon, you'll be able to clear out whatever is there or pre-written in your console. So now we are exclusively seeing what we're doing here. So 1 plus 2, and you say run, and you get 3 as our output. 3 plus 5, so I'm just putting it straight away here, right? So this is run again, x equals to. So what I'm doing now is I'm assigning the value of 3 plus 5 to x. So x is my variable here, right? So x equals to 3 plus 5. And then I'm asking what is the value of x. So it gives you x equals to 3 plus 5. This is the step that it has given. Then if I want to see what is the value of x, I'll write x, right? So when I write x, it is going to give me the value of x here. So I say run, and it gives me the value of x here is 8, right? I could also write print x, print and x, right? So now it will print the value of x. So I write here print x, and it gives me the value of x again. So x is a variable which has been equated to the value of 3 plus 5. Likewise, y equals to 5 asterisk 3. So you know the value of y would be 50. So you run, and because you've not printed y, you don't get it here. So let me say y. I'm just giving the variable name, and it will be able to give you the value of y here. So it says 15 here, if you see, right? Then, of course, there are other mathematical operations you can do. So this is the other mathematical operations. So you have 5 by 2, 56 by 10. Then all mathematical operations will follow the BODMAS rule. So first thing I want to ask you is, what will be the value of this equation? 2 plus in bracket 5 asterisk 3 divided by 2. Come on, mathematicians, quick. What will be the value? Give me in the chat. Everyone. Quick, what's the value here, class? Okay, so Shreya says 9.5, Sophia says 9.5, and 9.5 is correct. Everybody is correct. So there are other people also who say it. So Pranav says 9.5 and Shreya says 9.5. So everybody, you get it right. So let's just check if this is true. So that's 9.5. Now I change the braces here, and now you tell me what will be the value again following the BODMAS. BODMAS, you understand, right? Bracket of division, multiplication, addition, and subtraction. That's the sequence in which it will be operating. The operators will be used here, right? So now again, the second one, what value are we going to get here, class? Right, come on, mathematicians. Now remember class. Okay, everybody is good. So 10.5 is correct again, right? So everybody gets a 10.5. I see a 7.5 also. That's not correct. So, but it is understood, right? So good. So I think 10.5 is correct, right? So here you are. Then you could do a square root. So a square root, you could do SQRT and you say run and you get a square root. You could do raised power, but it's fine again, right? You could find what is the quotient and what is the remainder. So 10%, 56%, 10 will give you the remainder here. 6 is the remainder, 5 is the divisor. If you want to look at the divisor, again, you do this and you get the divisor, right? So this is some basic mathematical operations that you can do here. But of course, you're not going into R to do such simple things, right? So, and since I made some changes, I'll save it from here, right? So so now my script is having the changes that I made. I was printing the value of Y and X, which I had not printed earlier. So therefore, this is the change. You could select everything in one go and run again, right? That can also be done. Let me clear this out. And you say run, and everything will be running again and will give you the values here, right? And if you see here in your global environment column here, because you had used variables X and Y, now you have the values of X and Y shown up here, right? So this is the usage of the third panel here. It shows you the values of environment. It also shows you the history, what all you have done till now, right? So this is the history now. And this is the previous history, which I was trying to practice before the start of the workshop. And then it tells you the connections, not so much here, and tutorials. You could, again, go to tutorials. The link is given, and you could go here. So this is the utility of this panel here. It will give you the list of variables that are used here, right? And again, if you want to clear out the things, you can just use clear, and you'll lose everything here. And of course, you can use clear here and lose everything here. But of course, we will not use R as a calculator. I mean, because it is a statistical software, it is supposed to do much more than what a calculator can do. This any calculator can do, right? So therefore, now we move on to what is known as the data types in R. And what are data types? This is basically a method in which a data is arranged so that certain commands can directly work on this data, right? So this is every language will have its own data types. If you have learned Python I think the last few days, you would know there is a list, there is a tuple, there is a set, and then there is, you have strings and so on and so forth, right? So those are the data types in R. Likewise, in Python, likewise in R, you have a simplest data type that is known as vector. So we'll now go into vectors first, right? Class, the pace is comfortable to you? Everyone, raise hands. The pace is comfortable. Okay, so I see a lot of hands raised and good. So I hope you're following this, and it should be advantageous and useful to you. We are already into the half time now. Not that I'm concerned so much about time, but yes, I mean, it is also important that we don't rush through things. Otherwise, there's not much point. So let me now take you through a second script here, which is your R vectors, right? So vectors in R. Vector, right? So, all right. So if you see here, somebody is switched on the mic, right? So please, can you switch off the mic, class? Right? Please maintain silence and please maintain the discipline. Right. So I close this R as calculator. So now you know what is the scripting important for, right? So you could use this script as many times as you want and it will give you the same output. So that is important again. And now what I've loaded is a vector.r. In the interest of time, we could do it directly, but what I'm trying to do is to save time and still give you the maximum that is possible here. So we close this RS calculator. Untitled also we can close because there is nothing up here. So we don't want to save this, so we don't save. And now we are on a script that is vector.r, right? So the first important thing, vector is the simplest data type in R, right? It is a unidimensional data type. It contains some several values which are combined together into a single variable, right? So for example, here you are creating a data object, a vector with combine. So the C is for combine or concatenate. And what I'm saying is, let's say for somebody, I'm giving the marks in 6 or 7 subjects. So I say marks is equal to combine 85, 88, 90, 76, 88, 80, and 87, right? So this is the marks obtained by one student, right? And this is the marks that is there. And what I want to do here is, with this marks, I want to calculate the mean and also the median for this marks. Let's say this is what I want to do, right? So this is your basic statistics that we're doing here. So the first thing that we do is we create a vector, which is the basic data type in R. And a vector can be created by adding values in round brackets and appended and preceded by a C, right? And then this is equated to a variable, which could be any name. So I take it as marks because this I'm representing marks here. So marks equals to combine, and then whatever values you want to get are given within round brackets, so it's separated by commas. So this is the typical, the syntax for creating a vector. So marks equals to this here, right? And then of course I want to see whether my marks has been created. So I say print and in bracket the variable marks, right? So I run and I give here. And if you see immediately on the panel here, the variable panel here, the environment, you have the marks variable and the values are from number 1 to 7 and the values include 85, 88, 90, 76, 88, 80 and 87, right? So this is to indicate that this variable is now in the environment here, right? And then, of course, it shows me here print marks, and I could also say directly just marks, and it will show the values that are contained in the marks, right? So this is 85, 88, 90, 76, 88, 80, 87, right? Now, the first thing I want to know is whether I have input the marks for all the subjects or not. So I will check. Let's say I have 7 subjects. I will say whether my vector contains 7 values or not, right? So I'm saying length marks. So the command for that is I'm checking for the number of elements in my vector, and the command for that is length marks. And I say run, and I get the value of 7. So there are 7 values in my vector. And let's say I had 7 subjects. So now I know that I have values for all the subjects that I had included here, right? So length marks gives me the number of elements in my vector, right? Now, if I want to access my individual elements in a vector, right? So I want to see what is the first marks that I've entered here. So I can directly say marks, which is the name of the variable, which is the name of the vector here. And in rectangular brackets, I can give the value of the position I want to look at. Now, one thing that is important here is if you had done this in Python, you would know that this is in Python, the arrays or the list is 0 indexed. But here in case of R, it is 1 index. So the first item goes at the 1th position, the first position. The second item goes to the second position. In many cases, what happens is both in Perl and in Python, the arrays or the lists are 0 index. So the first item goes at the 0 index. Here in this case, it goes to the first position. So when I say marks 1 and I say run, you'll get the value of 85. If you were to declare a list in Python, then it would go at marks 0 position, right? So this is something that you need to keep in mind, that in R, the vector is 1 indexed. So the first item goes at the first position, not at the 0th position. Last, you're following everyone? Keep giving me some feedback and some encouragement, okay? Right? Otherwise, it feels like you're just, you're just talking and everybody. Okay, so I see a thumbs up here. Right, I see some more thumbs up here. Good, good. So it is important to keep this connection going. Class, everybody. So Nilima and everybody, and Vadya, and I see some names here. And I'm not taking all names because then, of course, we'll spend the time taking names. So good. Okay, and Raghuvanshi. I see only the part of Suchika or Ruchika, I think. So in my shared screen, I don't see the first name. All right, so good. So everybody is around and everybody is following, and which is the purpose of the workshop, that the introduction to R should be slow and progressive, and to the point where you know what is the utility, so that you're enticed enough. So this is more like a soup that we're serving you. And then, of course, if you're enticed enough, you'll go for the main course. Main course, of course, will depend on how far you want to eat and how far you want to learn, right? So coming back again here, class, this is the number of elements in a vector. So you do length marks and you get your number of elements here. Then you are accessing individual elements in the marks vector. So you give the position, and here the position starts from 1. So when you say marks 1, you get the value of 85. Then you want to see what is the summary of the values in your marks vector. So what you can do is you can use the command summary directly and say summary, and in the argument. So what you're doing is this is the command, summary is the command, and which vector summary you want to see, you are giving it in the brackets here, round brackets. So this is the argument you're giving, right? And then when you run it, it gives you the summary. So it gives you minimum value, it gives you the first quartile, the median, the mean, the third quartile, and the maximum value, right? So this is the direct statistical analysis of the data that is given in. So it gives you almost all the values that you want up here, right? Then you want to check what is the class of the data that you've given. So this is a vector. A vector could have a character class or a numeric class. So if you want to check that, the command is class, right? And this becomes important. Sometimes I'll show you an example where this becomes important. So here is your class marks and you run it. And this gives you that the class of the data that is included in the marks sector is numeric, because all are numerical values here, if you see, right? So when you define, all values are numerical, right? Now, if you want to calculate the total marks obtained by the student, so you can use the sum command, right? And now what I'm doing is I'm transferring the value of sum marks into a variable called total marks. And then I'm trying to also print it in a nice way. So I use what is known as the print command. And in print command, because I am using an alphanumeric character total marks, and then I'm using a numeric character, which is your total underscore marks, which is the value of the sum here. So you use an additional what is known as the paste command here, right? So this is how you would basically print out a result with the additional remarks that you want to give here. So I'm saying total marks is equal to, and then total underscore marks is where I'm calculating the sum here, right? So if you see, you run it, and you get your total marks equals to 594. So whatever you give here in this double inverted commas will come as such, and then the value of the variable that into which you have calculated the total marks will come here. The command is sum, right? So this is a function, right? So remember, so instead of saying x equals to 84 plus 85 plus 87 plus this plus this plus this plus this, and you could have 100 numbers here. So remember, what I'm showing you is on a small data, but actually the utility comes in when the data is huge, right? So, and always remember, when you make a program, first you run it on a small data so that you know exactly what is the expected output, so that you can match whether the expected output has come or not. And as your basic program gets ready, then you apply it into the larger data. In the larger data, the thing is that there may be some exceptions. So you may have to then deal with those exceptions in a separate manner. But whenever you're writing a program, first run it on a small set of data, which you can manually calculate and corroborate that what the program has found is correct or not, right? Because depending on what commands you use and how you use it, sometimes the logic may not be the correct logic, right? Of course, whatever you write in the program will be printed. So computers, as people say, garbage in, garbage out, right? So if you write a garbage program, you'll get a garbage output. If you write the correct program, you'll get the correct output. So coming back here, class, this is your sum. This is your, again, a function in R, which can directly total out the entire number of numerical values present in a vector, right? So this is your, and again, you select the part and you run, right? And once you run, in the console, you'll get the output here. And tomorrow I'll tell you how to write the output into a file also, because you cannot keep getting your output in the console and not write to a file, because ultimately when you submit your reports and everything, you need the data written onto a file that you submit. So tomorrow we'll talk of file handling in R, and I'll tell you how you can write back your data onto a file. Right now they're doing it all on console because we're trying to keep it simple and sweet, right? Then you can calculate the mean. So I use average marks as my variable, and then I say mean. And mean is again a function which is inbuilt into R, so you don't have to do anything. And you just have to feed in which vector you want the mean for. So when I say average marks equals to mean marks, it can directly give me the mean or the average for the data here. So I say run, and it says average marks obtained equals 35. And this is because I'm using the paste argument. So when I use paste, it is able to take both alphanumeric and numeric values and put them together. And what I'm also doing is I'm using a round command to round off the average marks. So it could be in decimals. If I don't use round, let me see what happens. So you could do a bit of modification here. So if you see now, I remove the round command, and then of course, if I run it again, so you see, you have a whole lot of decimal places that are given to you, and that may not look very nice. You can also control how many decimal places do you want the average marks to be printed, right? So I could also give a command that gives it only to 2 decimal places, which would be a nicer way of presenting it, because 84.85 is not the same as 85 as you see here. When you run it off, it becomes 85, but actually it is not exactly the same, right? So therefore, 2 or 3 decimal places is what we would prefer, so that can be done again. So this is your homework now. How do you print a particular numerical value until a certain decimal place, right? What's the syntax for that? Is your homework. You will do it, and tomorrow you'll tell me, right? You'll do it, class. Karoge? Come on, hands. Okay, so Neelama raises a hand, and everybody else. And I see the title Rasal, and I see Ruchika and everybody, right? And Srijani and everybody raises hands. So I guess we are going fine. So this is the homework. I mean, you should always have some homework in hand. Shashi Kapoor, Sahil Kapoor. All right. So good. So then we move on and we talk more about other measures of central tendency. So let's say you want to calculate the median. So you could directly say median marks equals to median again as a command. So remember also when you use these variable names, you cannot use a variable name that is already a command in R. You cannot say median equals to median marks, right? And also when you use variable names, it is important that you use a descriptive variable name. Descriptive variable name means that when you see median underscore marks, you understand, of course, that what you're looking for is a median. I could also say A equals to median marks, right? So I could also say A equals to median marks, but that would not indicate. And what happens in a short program, you will still be able to see the command and correlate that A stands for median marks. But when you write 10,000 lines of code, it gets really difficult to understand what each variable is doing. And A, B, C are only, 26. So how do you go beyond that? So therefore, it is always good to have a descriptive variable name, which is very indicative of what value it carries. So this is the median marks. Median marks equals to median and marks, and then you say run, and you are here, right? And let's say it is 87, right? And then, of course, if you move on further, and let's say you want to double the values in your vector, so you can directly say double underscore marks equals to 2 asterisk marks, right? So remember, your marks is your initial vector. So let me print the marks vector first, and then so that you have a comparison. So marks, right? So this is your marks first. Run it. And now you're trying to double every single value in the marks. So directly you can do double marks equals to, and this is of course a variable name, it could be A, X, Y, Z equals to 2 asterisk marks. And then you print the value of double underscore marks here. So you say run, and you get double the values 85, 170, 88, 176, 90, 180, 76, 152, 88, 176, 80, 160, and 87, 174, right? So you know now this is how it works out. You could also halve the marks, so you can directly say half the marks, and this will work again. You say run, and this will now you get the half the value. So 85 is 42.5, and so on and so forth. I'm sure you're following this. Then you could have two different vectors and you want to multiply them, and you could have actually vectors that have similar number of elements. So let's say you have a vector A, and this is basically, again, now you remember how do you specify a vector. You use a variable name, you equate it to something, and then you say concatenate or combine, and then give your numerical values in round brackets, right? So vector is the simplest data type in R. Remember that, right? A vector is the simplest data type in R. Ultimately, when we talk of data types, we mostly will be dealing with data frames, and we'll come to that in a moment. If not today, tomorrow we'll talk about data frames and other things. I think I will not overload you with things today, so we would stick to vectors today. Maybe I can just give you an example of a matrix after this, but for now we'll stick to vectors. So here you are, you're multiplying your vector by 2. So you have A equals to C, 1, 2, 3. B equals to concatenate again or combine again 4, 5, and 6. So these are two values. So what happens when you multiply two vectors together? So when you say AB equals to A asterisk B, right? So AB is the variable again, and what is coming up here is the product, multiplication product of these two vectors. So what would happen is individual, each position will multiply by the other position. So you have 1 into 4, 2 into 5, and 3 into 6. So let's see what we get in AB here, right? So you say run, and again, if you see, this is what you get. So 1 into 4 is 4, 2 into 5 is 10, and 6 into 3 is 18, right? So this is what you get here. You could also do a division here. So AB div is the variable I read. So I'm deliberately using a variable that gives me an idea of what I'm doing here. That is what is known as a descriptive variable name. And when you write your programs, you must always use a descriptive variable name. So here is what I do, AB div, A by B, AB div. And I say run. And now you get the values. 1 by 4 is, so if you see here, 1 by 4 is 0.25, right? And then 2 by 5 is, of course, what is 2 by 5 class? 0.40. And 3 by 6 is 0.5. And all of you class, those who are in biology particularly, and we all understand that everybody skipped mathematics and came into biology. But let me tell you, there is a lot of mathematics in biotechnology, right? And as we move into data analytics and biotechnology becomes the data analytics field, there is going to be more mathematics coming in, more mathematics than actually there is in maths, right? We are into neural networks and artificial intelligence and everything. And all of this is based on, basic mathematics here. So don't skip your mathematics. Also, if you're going for placements, some of you, most of you might be in your master's class and other things. So please ensure that you do mathematics every day. First round of placement is your quantitative aptitude, and maximum number of students get lost there. I'm telling you from experience. I was a placement coordinator at Amity, also at Chandigarh University. All right. So now, again, if you want to come back to the individual elements in the vector, so again, you can write AB1, and it gives you the first element. And remember, again, there is no zero indexing in R. It is one indexing the first element. So 4 comes up here, right? Likewise, if you write AB4, there is no fourth element here. If you see, there are only 3 elements in AB, 4, 10, and 18. So when you write AB4, you'll get a error message or NA message. So this is not applicable. There is no value in the fourth position in AB. So it gives you an NA, right? Then there are certain things that you can do in a vector. You could combine a vector to create a new vector. So you say Z equals to combine A, B, and A together, right? So if you remember, A and B vectors are, so let me just give you the values of A and B here so that you know what is your A vector. So I say A, I could also say print A, and I say B, right? So this is what A and B, and you get the values of A and B. So A is 1, 2, 3, B is 4, 5, 6. Now what I'm doing is I'm creating a new vector where I'm combining the values of A and B in a certain order. So I'm creating Z or Z, which is equivalent to concatenating or combining A, B, and A. So when you do that, this is the new vector you create, right? So let's say I say print Z. So when you print Z, this is what you get. 1, 2, 3, because the first vector was A, then the second vector was 4, 5, 6. So you have these values again, 4, 5, 6, and then the A vector again, so 1, 2, 3. So you could calculate the how many elements are there in this vector Z. So what is the command for calculating the number of elements in a vector class? If you remember, we've done it in the initial start. What command would you use to calculate the number of elements in a vector class? Anyone? So anyone who answers this gets a virtual chocolate, right? So I don't see anybody answering. Probably you might have forgotten. We have moved a little fast, probably, right? So the command is length, 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 and you say Z, right? So this will give you the number of elements in a vector. So you say length Z, and when you say run, it gives you 9 now, right? You see, so this is 1, 2, 3, 4, 5, 6, 1, 2, 3. There are 9 elements in the Z vector now. You're following class, everyone? Class, you're around? Okay, so Ruchika says yes, Chandani says yes, and I see some thumbs up here. Thumbs up, I don't see the first names. And Usha says yes, and raises a hand, and Shreya Prajapati, and Sophia, and everybody. Right. Thank you, and everybody is following, so it is good. And if you, just to remind you, we have done length here. We have done length marks, right? So because we've already done this, so this will give you the length of marks. It was 1, 2, 3, 4, 5, 6, and 7, right? All right, so we are doing good, right? We are doing good. So now what you can also have is a character vector. Until now we have had a numeric vector. We could also have a character vector, right? So for example, here I give a vector. So the vector variable name is my underscore name, and I say combine, and I say the first element is my, the second element is name is weapon, right? So this is what it is, right? And then of course I can print my name, and this will give me run here, right? And then I want to see what type of vector this is. Remember, when we talked of marks, we talked of again the class command, and I said class marks, and it gave me numeric. Now I'm looking at what is the class of my name vector, my underscore name vector. So when you say run here, it gives me character because this is no more numeric, right? It is mostly characters here, right? There is no numerical value. All right. And then if you say summary my name, so it gives me again a bit of summary here. Of course, you will not have any numerical value here, so it doesn't give you a mean or first quartile or second quartile. It just gives you the length, which is 4, 1, 2, 3, 4 elements here. Then it is class is character, and the mode is also character, right? And then I could have a vector that has combined values. So for example, here I am saying numbers vector equals to concatenate or combine 1, and then so 1 is a number here, 2 is a character, 3 is a number again, 4 is a character again. So what is happening here is this is what you define as a vector here. You say run, you get this one. Then you look out the values for numbers. So you simply write numbers or print numbers. And when you do that, it gives you run again. It gives you 1, 2, 3, 4, right? And remember, these are inverted commas here, right? So basically, this indicates that even your numbers that you've given are now being treated as characters. So you say class numbers. So you want to check what is being treated as the individual elements. What is their class? So you say class and numbers, and you say run, and it gives you characters, right? So now even your numbers that you put in a vector along with characters. So numbers also are now being treated as characters now, right? So you cannot perform any arithmetic operation on these individual values also. You follow class? Then in a combined vector where you have both characters and numbers, even the numbers that you give are treated as characters, and you cannot perform any mathematical operation on those numbers also, because one that you see here is not a number for this software now, for R. It is a character. You follow class, everyone? All right, so Shreya raises a hand, and okay, and everybody raises a hand, right? So I'll take it that everybody is raising. Not many hands raised this time, but yes, I can see thumbs up also as well. So then, if you see here, so num1 equals to numbers1. So you are now, what I'm trying to do now is to pick up the first character in my numbers vector and equating it to num1, right? So num1 equals to number 1, right? So numbers 1, so this will take the value of 1, right? Right? And what I want to emphasize here is how this works out. Then I print my num1, so it says run, and it gives you num1. Remember again, num1 is now carrying the value of 1, but 1 here is not a number, it is a character, because it's coming from a vector that has characters as well as numbers. So it is, if you see, class numbers is a character. So when you pull out an individual value from this vector, this is while this will show as 1, it will be treated as not as a number but as a character, right? So when I look at class num1, right? So what is num1? This is the first item in the numbers that are equated to num1. So I say class num1, and you say run. This is still a character. Let me show you a value of 1 here. It is still a character. It is not a numerical. It is not being treated as a numerical. If I say num1 plus 2, this will give me an error message because num1 is not a number. It is a character with a value of 1. So when you say run this, it shows error in num1 plus 2, non-numeric argument to binary operator, right? So binary, what is this? This is a operator plus, and it has been given a non-numeric argument because this is num1, which has a value of 1. but 1 is not numeric here, it is character. So therefore, num1 plus 2 gives you an error. If you still want to do this, then what you can do is you can use this command as dot integer num1. So now, while it was initially a character, it will be used as an integer, and then it is adding to a to 2, and it will give you the value here. So if you use this here, I think you can do this, right? So guys, I think, I mean, we can go on with this for some more time if you want, or else if you want, we can stop here. We have done the basic data type in R. Tomorrow we go on to matrix and data frames, and that should take care. And tomorrow we can have a bit of an extended session because I have planned to teach you a few things, and I won't leave you until I've taught them, right? And my students know that my classes get extended because there's not much point in doing a class unless the portion that is planned to be taught is not completed, right? So I am never finished with my course until the last class. There are faculties who finish 3 or 4 lectures earlier, but I'm struggling to finish the course always until the last class because there is so much to teach, right? So class, I hope you have followed till now. And then, of course, tomorrow we meet again and we talk more about it. So if anybody wants to say anything, please feel free to use your mic now, right? Or if you want to give, if you want to, tell me some feedback on how the pace was and whether good, bad, ugly, whatever, you can talk to me now, right? So we'll stop here for now. And then, of course, we meet again tomorrow and we move on to the next phase. And then, of course, if required, we can take one extra session sometime if the organizers permit, and we could do a bit of ggplot also. But I'll definitely leave you until matrix and data frames so that, and tomorrow we'll do a biological data so that you know exactly what we are doing. Of course, it will be a simple biological data. We'll talk of number of genes and gene density and other things. So this is what we'll talk tomorrow so that you have a basic idea of how this works out. So I hope all of you are okay with the way we've gone today. Give me some thumbs up, class. You guys have gone absolutely, ma'am. Okay, so again, it is Ruchika, Raghuvanshi, and everybody is Nilma and Tanmay and Usha and the thumbs up, Anil Kumar and Hassan and Rasa also. Good. So everybody is more or less fine with this. So I guess we can stop here today, and I see some claps as well, and Jyotsna, I think, and some good. So everybody, so maybe I can stop sharing so that I have my part of fun, so that I can see your messages clearly and good here. Very very good. So we'll stop here today, and we continue with this tomorrow, right? So take care, class, and also you need to be precaution. You need to take precautions against corona again. It is coming up again. Already there is a lot of problem in Delhi. So stay safe, take all precautions, and study well. Right. Ultimately, that is the way out. The more you learn, the more better you get placed, and the more you can contribute back to the society. Right. Thank you, class. On that note, we'll close here. How do I log out from here? So this is the first time. I think if host has anything to say, Dr. Mamta, you're around. All right, so we'll stop here, and I'll see you all tomorrow again. And my students can also send me messages on WhatsApp and tell me how it has gone, right, for your feedback. Right. Thank you, class. Everybody take care. And we meet again tomorrow at 7 o'clock. And tomorrow we may have an extended session until 8:30 or something. So eat well and sit on your laptop. Right. Thank you, class. Take care. Good night. I don't